Well, hello and welcome to the Bumper to Bumper podcast. I'm Dave Riccio, co-creator of Bumper to Bumper Radio and your host of the Bumper to Bumper podcast. I am joined by my co-host, John Riggle. Together with 75 years of combined experience, we are putting you in the know when it comes to your car. John, I can't stress this enough, and we talk about it all the time, batteries, batteries, batteries. And batteries will start the car, and people think they're okay because they start the car. But how many batteries do you test where the tester says bad? And it's pretty common, but it still
Well,
starts the car.
yeah, they start the car. Yeah.
Well, the reason in our testers are a bit predictive, so they're telling you, hey, you're about to have a battery problem.
Mm-hmm.
So they are predictive in that way. But when a battery gets weak, we end up with adaptation problems. And you're saying to yourself, I drive a car, what the heck is an adaptation problem?
Mm-hmm.
Well, adaptation is basically, I love the way you defined it. Before the show, we were talking about it.
Yeah.
What is a or what is an adaptation?
Adaptations, they're used a couple of different ways, but in response to, transmissions, we're talking about a compensation for in-use deterioration.
In-use deterioration. That's what you said.
Yeah, that's a term I like.
So and specifically we deal with a lot with transmissions, but adaptations are used really throughout the way the vehicle operates.
Yeah.
So we could take as things wear, okay, so things start to wear or things start to degrade. So as the battery degrades, as mechanically things wear.
Sure, clutches wear in transmissions.
Clutches wear in
So we
transmissions.
want to try to compensate for that. We extend the life of that transmission by doing that.
So it's adjusting. So the computer is compensating to give you a consistent experience while you drive the car.
Yeah.
So as something starts to wear, it gives. And I'll use transmissions because that's what we deal with the most. But as the transmission starts to wear, as the clutch begins to wear, it's going to increase the amount of pressure when it applies a certain clutch.
Mhm.
And not all, each gear is different.
Yeah.
This gear may be worn out, this clutch may be worn out. So it's compensating, and that compensation is stored in the keepalive memory or CAM memory in the car. So it's adapting to the wear of the vehicle. And I'm going to take it out of transmissions. The other thing you said comes up quite a bit is fuel injection is adapting as well.
Yeah.
So give me an example of that, like you mentioned voltage.
Yeah. So anytime we have a solenoid that operates, it takes a certain amount of current to make that solenoid open and operate like it should. When we have issues with batteries where voltage starts to fall off, if the voltage supplied to that solenoid falls off, we have to compensate for that one way or another. So we either have to turn it on sooner, leave it on longer, change the amount of pulse width to keep the same fuel delivery that we would have with more voltage. So we're constantly monitoring all these things and adjusting. And that's two-part because we have to compensate for the voltage, but we're also using the O2 sensors in the tailpipe for feedback. So we're controlling the fuel delivery based on what the O2 sensors say. So we are compensating for voltage, we're compensating for fuel pressure or variations in fuel pressure. All these things we're trying to compensate for.
So you made the point that anytime there's an adaptation, the adaptation is going to be in a system that has some sort of feedback loop to it.
Yeah.
So in a transmission, hey, we turn the solenoid on, and then we monitored RPM and those type of things to see how long it took a clutch to close.
Sure.
And then it looks at that time in the clutch and says, wow, that took 0.7 of a second to close that clutch. We got to bump that up.
Yeah.
And it doesn't do it on a one-off thing.
Yeah.
It's a progression. It's starting to see a consistent pattern in the transmission. It's going to increase that pressure.
Yeah. It'll watch in the short term. So we have like a short term learn and a long term learn. So we watch to see what happens immediately during our feedback as we make a change. We look, did the change achieve our goal? Let's make another change in the opposite direction or the same direction, whichever way we need to go. So it's constantly check, change, check, change, check, change. So when we wind up in a situation where I totally Forgot where I was going.
That's okay. But, you know,
I had a point.
there was a point to
I
it.
know there was a point there.
But yeah, so it's constantly adjusting. And so this is called the keep alive memory. And now when you clear diagnostic trouble codes in a vehicle, those are trouble codes. So the computer saw a fault. Sometimes it's got to see it a couple times, but this is going to say a code. Hey, it's a little pointer and say, look over this direction because we think you got a problem over here. So that's a diagnostic trouble code. Now that's different than shift adaptations, and just clearing the code doesn't necessarily clear the adaptations.
Yeah. So where I was going with that was we make these short-term changes. Okay, if we have to continue to make short-term changes over a long period of time, we'll go ahead and plug a number in. We'll add a little bit of change and put that in a long-term memory. So that's what gets stored in the long-term memory, right? So we've got this situation where we know that we'll use transmission clutches. Clutches are wearing. We know that it's taken longer to apply that clutch. Every shift, we will make an adaptation to see how the shift is. But over a long period of time, we've had to add a whole bunch of pulse width to that solenoid to get that clutch to apply properly and change the pressure. So that gets stored in long-term memory. If that long-term memory gets corrupted for any reason, because we had battery voltage drop or something like that, now we've got this situation where we've been adding a whole lot of pressure, and if we make a correction or something, or we lose that adaptation, now the transmission's not going to work right.
You know, some of the early GMs, they had a code, P1811, and that code, the little brief definition of it is maximum adapt.
Yeah.
So, in other words, we've turned up, you know, and I always kind of make the valve analogy, like when we're turning up the amount of pressure, as a clutch is slipping, it's going to feed it more and more and more pressure. Well, at some point, it's got no more pressure to give it, so it's a maximum adaptation, and it turns on a code. It says, we can give you no more to compensate. You are worn out. You got to go to the shop. So maximum adapt, I think it says long shift.
Yeah.
I think that's the name of it. And right now we have in our shop 2 vehicles that are there because of battery issues that are causing transmission issues. We got a Jeep, can't keep track. Is it a Renegade? No, it's not a Renegade.
It was a Cherokee.
Cherokee.
Yeah, it was a Cherokee.
And that's got, I believe it's an 8 or 9-speed transmission in it. And you'll be driving along at 40 miles an hour and wham.
Oh, yeah.
Yeah, man, I mean, you think it's going to, you think the axle is going to be floating down the road coming out behind you. It shifts so bad. And it's very intermittent.
Yeah.
And what that one was, and first thing you do, you pull in the bay, you test the battery. And the battery, you test it. Okay, test it bad. Test it again. Make sure we don't have a fault test. Test it bad again. Still starts the car, still operates. Very good indicator, and it's something you file away as you go through your diagnostic and look at the fluid and look at all the other things. And ultimately, the fix on that car was to put a good battery in it and then clear the adaptations. And then some of these vehicles, they have a test drive that you do to specifically learn that computer quickly.
Yeah.
So you may go, you know, I'm just trying to think of some of the ones that are more complicated to learn. But man, these 10-speed transmissions, right?
Oh, the eights and 10s. Yeah. Well, we can do selective relearns on each clutch, each shift. Some of that gets pretty involved if they get corrupted and they get way out. This one was weird because it was intermittent, and the only thing I can figure is that it occurred during a certain load and speed issue. It was when I was starting to accelerate at 35, and it locked up the converter, and it did something there. It was right on top of the shift or something. And this thing, man, when it would hit so hard. I was like, wow,
what happened?
Yeah,
Is the transmission laying in the road?
Yeah, but you know, I had to keep looking at it. I'm looking at it. It's got like 60,000 on the clock, and I'm like,
oh yeah, nothing really wrong with this thing.
You know what? And yeah, and when I saw it fail the battery test, I'm like, you know, I wonder if this is all adapts on this thing. And
so most commonly, we're dealing with shift adapts. Some of the other systems, John, fuel pumps actually adapt.
Yeah, because we're running those. Yeah, we're running those in a feedback loop. We're watching the pressure. We're watching a lot of the fuel pumps are variable speed pumps now. Variable speed pumps are quieter, last longer, things like that. So we're using these variable speed pumps. Well, as bearings tighten up or wear or whatever, we got to adjust the amount of time that we keep that pump energized.
Fuel pumps, there's some adaptive there. Fuel injector is definitely adaptive there. Charging systems. So your alternator is not like the old days. They had a regulator in it and it just kind of did its thing. But now they're totally computer controlled. So it's pulling. Hey, we need more. We need less. And so as the alternator wears or as things wear, it's going to adjust there.
Well, as the battery degrades, that's what it's one of those reasons why when we put the batteries in the BMWs, we have to register the new battery because this thing's been watching over a period of time. They know that battery is going to degrade, right?
Right.
So they watch how much current they have to put into it. They watch the voltage, and they try to charge this. There's rates where you don't want to overcharge batteries. You don't want to undercharge batteries. It's a real kind of balancing act to make a battery last as long as it should. So they use these essentially adaptive strategies to maintain the charging system, maintain that battery as well as they can. So when we replace the battery, like the BMWs and stuff, we have to go in and tell it, we replaced this battery. This is a new battery. So you're going to have to start over and assess this battery differently than the last one.
It's not like the old days where you just put a battery in the parking lot out in front of the auto parts store. It can still happen, but depending on the car, certainly certainly makes a difference. Okay, and the other one I was thinking about is idle speed or throttle bodies. That's a biggie when you change a battery. All of a sudden, the car won't idle.
Yeah,
I've seen that happen.
Yeah.
So, but throttle bodies, it's again making adjustments. And you change the battery out and it's adjusted. And the other thing with idle speed is cleaning that throttle body because the computer is going to be compensating for a dirty throttle body.
Yeah.
As it gets more dirty, it's got to throw some more opening at it to make sure this thing stays in idles. Right. And you clean out that throttle body. Well, now there is a relearn process for the throttle body, much like for the transmission.
Yeah. So these things are adapting all the time. Some people think they adapt to the way you drive, and we hear that a lot. Yeah, it adapts to the way you drive. Kind of, sort of. It doesn't really care so much about how you drive.
Not a personality test.
It's actually looking at other things. So there can be situations where if you don't drive a car aggressively enough, you'll never get into these kind of load ranges and things where the adaptives would adapt to it. So in a way, they do adapt to the way you drive, but that's
a minute part of it.
Yeah, that's a stretch,
For sure. So keeping a good battery in the car, we can't stress it enough. We are in Arizona, so in Arizona, battery. I mean, if you get 2 years out of it.
We really hammer on batteries. But here we are. I've got 2 more cars this week. The one with the bad cell out there.
Yeah.
It's like that car started and ran, but you wouldn't.
It's the last place to, I don't want to say cheap out. It's there's a lot of electronics in your car, and you take some of these modern cars. There's a computer for everything.
There are electronics in every aspect of that car. Every place that people think that this brakes are easy because there's no computers involved. Oh yeah, there is. Yeah.
When you realize how many little tweaks and adjustments the computer's making all the time to make that car, not only, they've tried to wring these things out as far as getting the most efficiency out of everything.
Oh, big time.
It's one of the reasons, you run the alternator less, not only does it not overcharge the battery, but it's also less load, less fuel.
Oh, yeah.
Less fuel's burned up.
Are there some of these cars that idle in here? They shut the alternators off.
Yeah, because you don't need it.
You don't need it. If there's a certain situation where you don't need it, if battery's fully charged and stuff, we don't have cooling fans running or something. Let's turn the alternator off. It's, there's no reason to have it sitting there, overcharging that battery or cranking.
So it's the place where you don't want to go cheap is on that battery. And what I mean by that is that it just should be built into the expense. It's one of those deferred, tell people the battery's weak. That's okay, and they may run it, but it can be doing damage to things, not only adaptations, but just other components. For instance, someone's dealt with a bad battery for a while and they just kind of nurse it along, right?
Oh, yeah.
Or they don't know it's bad. Well, what happens is we put a battery in their car and 2 weeks later they need an alternator. Well, the reason they need an alternator is that alternator's been compensating for that bad battery.
Yeah.
So deferred maintenance and deferred repair ultimately cost you more money because you're like, I'm going to make that battery go because it still starts the car.
Yeah.
Well, that battery, now you got a $600 alternator down the road because you didn't put a battery in it.
That's my big beef with bad batteries, sulfated batteries that require the charging system to overwork itself trying to maintain that voltage and current for that battery. That's the biggie, because you don't spot it. You don't know it going down the road. It's one of those things that, and like you say, that car starts perfectly. Can't have a bad battery. Could be totally wrong on that.
I would say that a lot of the hard diagnostic problems that roll into auto shops and the reason you test the battery first, they're related to a bad battery. Just because dropping out, we lose adaptive memory on something, or things just aren't jiving right. Now we got a hard diagnostic problem. Well, thanks for joining us on the Bumper to Bumper podcast. We'll be back for more to teach you about your car. Well, hello, I'm Dave Riccio, your host of the Bumper to Bumper podcast, and I would like to thank you for tuning in. If you want one of your car questions to be answered on our podcast, tap the link in the description for a chance to have your question featured. And while you are there, we would love for you to like and subscribe to see more Bumper to Bumper podcasts in the future.